of our ITR. I welcome you all to the Soawal webinar. This is the 13th one, and today we have Dr. Abhinesh Kaushik sir. Uh, Sir, we are very much obliged to having you to our talk. So I would like to start the webinar with the introductory video of our university, which is Shiksha Anushandan. Then I will formally introduce you to our audience. And so I'm going to play an introductory video of our university, sir. Sorry. So that was our introductory video of our university. So now we can move forward. So we have Dr. Abhinesh Kaushik sir. Dr. Kaushik, hello. Yeah, Dr. Kaushik actually received his PhD and MTech in computer science from the School of Computer and System Science from Jawaharlal Nehru University, New Delhi, in 2001 and 2021 and 2016 respectively, and B.Tech in Computer Science and Engineering from Guru Gobind Singh Inprus University, which is also in New Delhi. In 2013, he has worked with HCL Technology and Bharat Electronics Limited under Ministry of Defence, which is a public enterprise between 2013 to 2015. He has also taught at the University of Delhi from 2020 to 2021. So he is currently working as an assistant professor at the Department of Information Technology and IIIT Lucknow, which is Indian Institute of Information Technology, Lucknow, Uttar Pradesh, India. So his research interest includes localization in wireless sensor networks, and mobile ad hoc networks. He has published articles in international journals of international reputed journals, including Springer and Willie Taylor and Francis. So he is also a reviewer for the Journal of Supercomputing and International Journal by Springer. So, sir, you can share your screen and start your presentation, sir. Hello, am I audible to you, sir? Hello.
Yes. Am I audible?
Yeah, yeah, you are.
Actually,
Yeah.
there's a slight delay in your voice. The voice is like it's coming twice. One is in sync, and other one is a bit delayed.
Yeah, hello.
Uh, yes. Am I audible?
You are
Actually,
audible, sir.
delay in your voice. The voice is like it's coming twice. One is in sync, and other one is a bit delayed.
Yeah, hello.
Yes. Am I audible?
You are audible, sir.
Okay, fine. Okay, so first of all, a very warm evening to all the uh, people present in for the webinar, and thank you so much, the Mr. Shabab Anwar, for giving me this opportunity. Okay, so let me just quickly share my PPT, and I'll
So,
start.
Abhinesh,
People present in.
good evening.
Thank you.
Sir, I'm sorry to say that your voice is echoing. I don't know how you are receiving our voice, but I think if you log out and log in again, it may be better. Your voice is
Oh,
otherwise echoing, sir. So,
okay. Let me do that.
Abhinesh, good
Let me
evening.
do that.
So, sir, I'm sorry to say that
No problem. Let me do
I
that.
don't know how you are receiving our. Shabab sir, I thought I could. That would be the better way. So I had to suggest him. Sometimes relogging actually helps.
Okay, ma'am. So actually I weren't able to figure out where means I am having the problem or he is having the
No, no,
problem.
but after you said, I realized that we both are having problems. So I thought,
Okay.
like,
Your voice is quite clear.
yes. So I think sir has, if he relogs in, I think it would be better.
Yeah, I think he is joining again.
Am I audible now?
Yeah, your voice is quite fine this time.
Yes, sir.
Oh,
It's so good. Thank you,
Uh,
sir.
okay. No problem. Thank you so much. Let me just share my PPT quickly. I hope my screen is visible to everyone.
Yes, sir,
Yes, sir.
it's visible. Yeah.
Okay, okay, great.
You can go to the presentation mode, sir.
Okay, yeah, okay.
Yeah, yeah, it's fine.
So, a warm, a very warm good afternoon, good evening to everyone. So, Mr. Shabab has already given my introduction to you all. First of all, let us see why I am giving you a talk on like databases and wireless sensor networks. There are more research trends like machine learning, artificial intelligence, and things of that sort, big data, and of the all those things. Why I choose this topic? See, what we see in today's world is everyone is running after cloud computing, be it cloud computing or artificial intelligence or machine learning or big data or data analysis, everything. But what we forget at the end of the day is the core thing from where everything has evolved. Okay, so when we look at the topics like data analysis, big data, and all those stuff, they come from the basic, that is your databases. Okay, and when we look at the techniques like artificial intelligence and machine learning and things of that sort, they are basically techniques, they are not research trends, or they are something, this is something like a methodology which can be applied to a lot of things, that can be applied to various fields also. So when we talk about research and when we talk about what we do in terms of studies in our technical education, that is your engineering, we sometimes see that we are studying database, but at the end of the day, sometimes people feel that they don't get to connect with the industry, and they don't get to see the real connection between what they are being taught in the college and what they have to do at the end of the day in the industry. So that is the reason why I chose this topic. Okay, and I'll come to the wireless sensor network part also. First, I'll start with the database part. Okay, so we all know what a database is, right? We have various types of database. Earlier, we used to have the most common type of database was the SQL database, okay, structured query language database. But nowadays, what we have done is we have shifted to non-SQL database. That is your MongoDB. Why did we shift it to that? Because see, in the SQL database, everything was done in terms of tables and fixed formats of tables and fixed columns, and everything was fixed over there. Okay, and we could do whatever we could do was in terms of the tables only. But this non-SQL databases, that is a very common example of that is your MongoDB. In that we can have various and variable fields. Okay, we don't need to stick to our columns which were predefined. Sometimes we have a kind of data where we might not have like for example, you have 6 columns in your table, and the real data which we get from the real world might not fit into those six columns in the table. Okay, that it might be possible that the data might not be of the same type for which the table has been already created. So in those kind of databases, or in in those kinds of data, comes the role of your NoSQL database. That is your and finest example is your MongoDB. Then we move to the next stage. That is your, see, the basic is the database. Okay. Then from the database itself, we move to a higher entity, that is your big data. What is big data? Big data, when we talk about big data, what we are doing is we used to talk about 5 V's earlier. 5 V's were velocity, volume, and variety. That is to say that the data is very voluminous. Okay, the data is being created at a very high speed, and the data is of different types. Okay, so what we've done is we've evolved from database to big data. Big data is nothing but a form of database only. The only thing is that the speed of data which is there in the big data, it is increasing at a very high speed. Then the second thing is, when we see that this data is of very, not just increasing with a very high speed, it is also using a lot of space. when we talk about normal databases, what we use, for example, your university might be using a database. When I talk about that database, we see that that database might be like it might require 2 TB or 4 TB of data. Okay, but when we talk about big data, we talk in terms of petabytes. We talk in terms of byte data which is greater than petabytes also. Okay, so it is like it is the evolved form of big data. Okay, then the third thing which we come to is data mining. Okay, this evolution is from the database only. Then we came to the database, then we came to big data. Then we have the when the data became big, it became difficult for us to represent the data, or because see, the data which we were getting in the big data, it was of variety of types. Okay, I hope you all are following. Yes.
Yes, sir. Yes, sir.
Okay. Okay. So see, what we were doing is when we came to big data, the variety of data increased. Okay. So when the variety of data increased, it became difficult for us to it became difficult for us to find meaningful data out of it. Okay. So we developed a technique called data mining in order to find the useful data or the useful information from the big data that was generated. Okay, data mining is, as the name itself suggests, we are basically, what does a mine do? When we look in like a general English language also, when we talk about mining, what does mining mean? Mining basically means to finding out precious metals or precious whatever is required from a place where it is found in abundance and it is mixed with a lot of impurities. So the same thing goes over here. What we are doing is we are having a lot of data, we have heaps of data, and we are trying to find meaningful data out of it. Okay, so that becomes a data mining. Then that data that has been mined from the database or the big data, that is now analyzed. That becomes data analysis. So can you see the correlation between these? It is all evolved from the database itself. It has become a new field. See, this database was a small basic concept which was taught in our colleges. Okay, and then this big data became the industrial thing. Okay, and then we did the data mining. We are just basically finding out the meaningful data from it, and it became a whole new field, that is your data mining, because of the process and because of the tools which were being used. So it became a new field. Then data analysis. The only thing we're doing over here is the data which we have mined from the database or the big data, that is being analyzed over here. Okay, so this becomes another field in itself. Okay, then we have one more broad field, that is your data science, which includes the applying of the concepts of artificial intelligence using the big data and doing the machine learning using neural networks. You can apply a lot of things to it. If we go by the general name of this thing only, data science. What does data science means? Science of data. Okay, science, when we talk about science means we are talking in a very broad perspective. We are talking the functioning, or we are talking the basic usage, or we are talking about the basic application and disadvantages and everything about data. Okay, so in big data, what we are doing is the data mining part which we were doing in the data mining. Here what we have done is we are doing the analysis only, but now we are doing an advanced form of analysis where I can apply my machine learning and artificial algorithms to it in order to find the structured and semi-structured kind of data. Okay, artificial intelligence and machine learning are just techniques. Whenever see we whenever we at IIIT Lucknow, we sit an interview for PhD candidates. We find a lot of students who come to us, and when we ask them what do they want to research in and what field they want to choose, a lot of them tells us that it is artificial intelligence or machine learning. And to them, my basic question is remains always the same, that artificial intelligence and big data cannot be a research title or cannot be a research field, because they in itself are techniques, they are not research fields. Research field is something like, for example, databases. Okay, you can choose a database as your research field, and then you can apply different artificial and machine learning algorithms to it. Then again, you have wireless sensor networks as a field, and you can apply a lot of wireless concepts and things of that sort to it. Okay, then we see these were the basic fields which have evolved from the databases. Okay, and now let us see what are the application of these databases which we see in our daily life. Okay, you must have seen, you all must be using apps like Amazon, Flipkart, and other shopping apps. Okay, so what does these apps do is they keep a huge amount of data. Whatever you do in these apps, for example, whatever you are surfing on them, whatever you're searching on them, and whatever you're buying on them, they keep a track of all your spending habits and what kind of things you are searching for. For example, you have a wish list, right? So in that wish list also, that is kept as a data for data in a data container for the individual customer. Okay, and based upon that, the recommendations are given to it. So just think about it, that this is, I'm talking about just one person, and there are millions of people who are using the app at the same time. So you can just think of the huge amount of data that is being created at the speed with which it is being created, because we are shopping like anything, and we are doing everything is these days are being done on, everything is done on mobile phones itself. We hardly use our computers until and unless we need a data intensive or a very high load data which needs processing power of a computer. Otherwise, most of our things are done on the apps only. So these apps are in the back end using your big data or your data mining and your data analysis techniques, and these are basically tracking your spending habits. Then recommendations, again, this is a supplementary point of the first one itself, that based upon the habits that it keeps, or based upon the recommendations, or based upon the shopping experiences, or based upon the wish list you have kept, it gives you recommendations on that. Then you have smart traffic system. What is a smart traffic system? These days you might have seen that metropolitan cities or capital cities, what they're doing is they're installing cameras in their main cities, and that camera creates a huge amount of data. If you look at it at the state level or at the country level, that creates a huge amount of data. And for example, if you want to look for a specific clipping of a specific incident that has occurred at a specific place in a state, then you just consider the amount of data you need to look into that. So there comes your application of big data, data mining, and data analysis, all of that. Then you have secure air traffic system. Again, the earlier I could say that there wasn't a requirement of uh, I mean this much amount of data in the air traffic system, but considering the affordability and the increase in the air traffic market, we seriously need secure air traffic systems, because of the increase in the air accidents, and uh, because of the advancement in the field of air traffic system. We need to analyze that data also, and we need to improve upon that also. We have self-driving cars. Okay, self-driving cars are an example. See, they're already being tested and they're already being used countries like US and UK. Okay, they are yet to come to India, but they also generate huge amount of data. They generate tera and petabytes of data in every, not in every day, but in every 6 hours or 7 hours. So that amount of data has to be stored and that has to be analyzed. Okay, and so that includes a lot of data analysis, and to find out the, like, what do you say, find out meaningful data out of it. Okay, let me just give you an example of this self-driving car. Give me this just gave me an idea of that only. How many of you have seen earlier you used to use captcha for jumbled up words, but now we do have captcha where you have to find traffic signals, where you have to find cars, where you have to find boats, where you have to find hills, where you have to find things of that sort. You must have observed that. Yes or no, guys?
Yes, sir.
Yes. Do you does anyone know what is the logic, or what is the science that is behind that? Why
No,
have
sir.
they shifted captcha to that?
Yeah, exactly, sir.
See, this is what. Yeah, yeah, please. Someone was saying something.
no, sir. Actually, your voice is breaking sometimes.
Okay, okay, okay. This let me tell you what uh, is the science behind that. What see, what you see is you are basically solving the captcha problem, but at the back end, what Google is doing is Google is using your processor, your processing power, and your intelligence to train its self-driving cars. Okay, what Google does is Google basically trains its self-driving cars by your intelligence. It is using machine learning algorithms where you will help Google find what are the traffic lights, what are the road signs, and things of that sort, whatever you get these days in terms of captcha. Google is using your intelligence, and it is training its models so that they can be used in the self-driving cars. Okay, so next time when you see that kind of a captcha, just think of that why do you always get captchas in terms of road signs and things which usually appear on the road, or which are somewhere or the other related to road. You might sometimes see pixelated images over there, you might see very high definition image over there, sometimes you just see lines over there. That is basically Google is using your intelligence to train its self-driving cars. Okay, then you have virtual personal assistant tools. What are virtual personal assistant tools? You all must be aware of Siri and Hey Google, right? All of you must be using that. What is that? See, when you say that, for example, I say, okay, Google, tell me what is the temperature in my city today. So what does Google do? Do you realize what type of analysis that is being done and what type of data is being used behind that? Give a Siri. See, when I say what, tell me, Siri, what temperature what is the temperature at this moment at the place where I'm sitting? So Google, they basically analyze your location, they analyze your position where you are. They analyze the air quality, and they analyze the temperature at the place. They analyze all the types of information which are related to you. It correlates to that information, and then uses the machine learning and artificial intelligence techniques to find the information which you're looking for. Sometimes you say, you ask Siri or Amazon to just play something, Alexa or anything of that sort, virtual personal assistant, to play music according to your mood. How does it know about your mood? Because it is analyzing all your data, it is analyzing all your apps, it is analyzing all your browsing history, it is analyzing everything. See, consider you just do one thing today. Just check, those of you who are using Android phones, just check the cache of your Google app. You must be having a Google app in your phones. Just check the cache of that. You will be amazed to see that it might be using 1 or 2 GB of your space, and and sometimes it might be just in hundreds of MBs. But why is it using hundreds of MBs of data? Because it is analyzing all your search results, it is analyzing all your browsing results and everything, and then it is personalizing and giving you results based upon that. Okay, then the next application comes as education sector. Education sector, see, the revolution in the education sector itself. See, you all must be aware of NPTEL. You must be all be aware of uh, see similar kind of infrastructures and similar kind of platforms where see these days there are several kind of infrastructures where people are like giving holographic lectures at a place, right? That is possible because of the big data and because of the high speed data, because of the 5G and the high speed data that is available. Okay. Then in the media and the entertainment sector, you all are aware of the news channels, the kind of uh, entertainment they give you. They give you 3D graphics. They give you all kinds of uh, uh, I mean cartoonish things and all kind. They give you all kinds of what do you call it, animated things and VFX effects which you see in your movies these days. All of that is because of the big data, and that is because of the high speed internet that is available to you. Energy sector, see, these days what happens is you have smart meters. What smart meters does is it sends all the information, the whatever data is or whatever are your electricity patterns. They just analyze that and they send it to a server, and the server analyzes that and just sees, and the power grid at the end of the day analyzes the amount of energy, and they just see that what is the peak time where when the highest amount of energy is required by the homes. And based upon that, they tell the manufacturing sector that at this point of time you can get uninterrupted power supply because the peak load is less at that time, so we can provide you additional electricity over there. So that is again using the big data. IoT. See, these days you see that all your air conditioners, your mobile phones, your virtual personal assistants, your smart speakers, your washing machine, even your homes, everything is connected to the internet, and all of that is analyzed, and you can just give a command on your phone and you can switch off your home, you can lock your home, you can switch off your air conditioners and washing, you can control your washing machines using that. Let me give you one more example how, see, not just uh, private companies but even the government is using this big data in a very very interesting and in a very what do you call it, in a very advanced way. See, I was reading before every budget you get an economic survey. Okay, so in a year or before, I was reading the economic survey, and it said that they have used big data, and they were using. See, you would be amazed to know for the reason they were using big data. They were using the big data to analyze the GDP of, per capita income of every state. And how were they calculating that? What they did was they analyzed all the like in uh, in the entire country. What they did was they compared the prices of or the cost of veg thali and a non-veg thali. Okay, and just see the amount of data they might have analyzed. If, for example, a restaurant has a footfall of around 100 people, okay, so and 75 of them have veg thali and 25 of them are having a non-veg thali. So they are analyzing all those bills. See, this is about one restaurant, and a city might have 100 other restaurants, and multiplying that with the number of restaurants in a state, and then multiplying that with the number of uh, what all the restaurants that are there in the country. They have analyzed that, and based upon the veg and non-veg thali, they have uh, analyzed and they have given the per capita analysis of every state, for a veg person and for a non-veg person, and the amount of amount people were spending 2 years ago, and the amount people are spending 2 years. In the present time, they are analyzing the per capita income based upon that. Okay, so that is basically the use of your big data. Okay, then the challenges you usually face in these things, these evolved fields from databases. For one of them is your sharing and accessing of data. See, this is a huge amount of data. Even the data that is stored, you're just using your Amazon app, okay, and the data that is being stored with Amazon for a individual person, if you analyze that data and if you ask them to give you the entire data, you will be amazed to find the uh, you will be amazed to find the volume of that data. Okay, and just think of that, that data, if it gets into others hand, what kind of uses they can do for that data. Just let me give you an example of this sharing and accessing of data only. You all must have seen that sometimes what you do is you search for something, and uh, whenever you open other apps on your Android, you get recommendations of that only. Okay, so that is what this Google is doing. See, you use a Google web view settings app, and that basically is the base for all the Android apps which are being used in your mobile phone. Okay, so that is being shared across all the applications. That is the reason why you see advertisement of what you have searched for in all your apps. So it makes it pitches up for a concept of privacy and security also. See, we individuals, or we as a population, have a very thick tendency of having every time blaming every time government for everything. See, government is analyzing things, government is using big data, government is actually using big data in terms of Aadhaar also, right? If you see, if you look at the amount of data Aadhaar has, and the linking of everything with Aadhaar. See, we always blame government, that government uh, will evade our privacy or evade our security. But government, if you compare it with the amount of data Google has for has yours, you will be surprised to know that government might not even have 10% of your data, but Google knows each and everything about you. Google knows where you go, Google knows what is your current location because of the GPS. Google knows where you go. Those of you who are using maps, you must be getting a monthly timeline to where it tells you whatever places and whatever routes you have taken in the entire month to be there at that place. Okay, so that is the amount of data that Google keeps. So that calls for a concern for security and privacy. Then you have analytical challenges. Then analytical challenges is again the thing, like you have to analyze your whole lot of data, and then you have to think of how do you analyze that data. Okay, then you have technical challenges as well, that the quality of data, it is not always possible to distinguish quality data from the data of the heaps of data or the big data. Sometimes you need a very specific kind of data, so it is a challenge to find that data in that. So that opens up a research field again for the quality of data as a technical challenge. Then fault tolerance. Then see, if what happens, you must have observed a few days ago that there was an outrage on WhatsApp. So all of you were stuck with that. So because, see, that is what we call fault tolerance, that if in any case, or if at any point of time, if the system fails by any which means, then there should be a contingency plan for that. If the system fails, then it should move to the other backup system so that the services don't suffer. That is what happened in case of the WhatsApp in a few days ago. Then we have the scalability. Scalability is again a very big challenge, that we do not know what scale of data we have. We have a huge amount of data. We cannot predict about it, that the we cannot say that only 1000 TB of data is sufficient. We cannot say that 1000 petabytes of data is sufficient. So we need to look on the scalability aspect of that also. Okay, so that was all a basic overview of whatever has evolved from a database. So whenever anyone wants to research in case of anything related to these things, they should focus on the primary thing, that is your databases, and not on the outer layer. Or I hope people will not next time when they're asked what they want to research, they will not say that I want to do research on machine learning, and I want to do research on artificial intelligence. And they might give and specifically not big data as well, they might give you a solid you people might give me a solid or uh, solid field based upon these. Okay, so these were all your derivatives from the databases only. So the whatever I don't know what kind of audience is over here. If we have BTech students as well over here, so if you people are studying databases, then just study it very thoroughly, so that because everything you will do related to data in the industry or in the higher classes, that will be all related to the databases only. Okay, so the next field is your wireless sensor networks. This is basically the field in which I work. Okay, so what do we basically understand with wireless sensor networks? Wireless sensor networks, see, whenever we want to know the basic definition of something, the best method to know the I mean the overview of the topic is to go by the dictionary meaning of the each word. When we say wireless sensor networks, so first thing is wireless, so we are not concerned about wires over here. Then we have sensors, so basically this involves sensors. Then the network, then you all must have read of studied computer networks in your colleges and schools. Okay, so what we do over here is we are talking about networks which are made out of sensors which are wireless, okay, which do not require any infrastructure. So why do we require these kinds of sensors? See, for example, uh, these days our world is full of sensors only. You have a lot of type of sensors in your mobile phones. You have gyroscopic sensor, you have light sensors, you have uh, n number of sensors over there. Okay, you have sound sensors, you have uh, uh, pressure sensors, you have temperature sensors. So all of these are used in many of the ways. Okay, so why do we need wireless sensor networks? I'll give you a very basic and very relevant example of this. For example, we all of you must have heard of mishaps that occur in case of coal mines and leave alone coal mines. All of you are aware of forest fires that take place in the season of this May to June. That is scorching heat. When there's a scorching heat on the Indian subcontinent, we see a lot of forest fires over there. Why are we not able to keep a control or keep a tab on that? See, if we use these wireless sensor networks, we can deploy these sensors over there, and they can detect the fire in the forest, and they can relay the information to us, and we can get to know that well in advance. And whenever this fire that starts with a small point, we can ward off that, and we can uh, prevent the higher destruction over there. Okay, and in that happens in case of coal mines also. See, what happens is we Indians are usually using the very traditional method of coal mining. So what we can do over here is also that we can deploy sensors over there, so that whenever a mishap occurs in a coal mine, or whenever sometimes it becomes very difficult for us to find the workers which were working in the mine, to detect them wherever the mishap happened, and to detect where the workers were and where they're not. It becomes very difficult to find the bodies also. So what we can do is we can deploy sensors over there, and we can see if that place is still buried, or that place is still active, or whatever. Are we still getting signals from there? And we can pinpoint and find the location of that uh, place where the mishap occurred. Okay, so these can be the definition. These can be the applications or usages of your wireless sensor networks. Then you have there are application in this thing battlefield also. Okay, so let me give you a very current example also. See, there's a very upcoming field called, you are all aware of Internet of Things. I just gave you a brief example of that. So can you see that there's one more thing? See the correlation between the two. We are writing Internet of Things as an application in databases also, and in the wireless sensor networks also. So basically, when at the end of the day, when you see that both of the things are basically narrowing down to one thing only. Okay, so okay, yeah, I was giving an example of this internet of battlefield. That is a very upcoming field. You all must have seen in the news today that there are drones which are coming from the border area, and they're dropping weapons over in our territory, and they're just leaving. So if we have better sensors, if we have sensors to detect these drones over there, we can avoid the manual intervention over there, and we can just use our uh, tools and weapons effectively in order to destroy them at the border itself. Okay, we can use these sensors. For example, you all must be aware of the these what do you call them, strikes which we did in the surgical strikes. Yeah, surgical strikes and the surgical operations which we do. These sensors are these sensors play a very big role in those also. Those are part of your internet of battlefield. That is a very upcoming field. So we need sensors at the borders, we need sensors in the battle area, we need sensors in the war field in order to sense a lot of things over there, in order to see whenever there's a uh, bomb, there's whenever you deploy, or whenever you release bomb at a place, the temperature of that place decreases, so it increases. So basically you can sense the blast of a bomb also with this with the help of these sensors. Then you can monitor, or you can put things in surveillance using these sensors also. Then you have environmental, you can obviously, like I told you, in case of forest fires and in case of coal mines and all, you can use these sensors to find the uh, air pressure and things of that sort at those places. Then you can also use them for uh, detecting the noise level of the surroundings. This again finds the application in the internet of battlefield. See, whenever, for example, there are a number of cases of terrorists intruding into our territory. So we can use these noise sensors over there to find if there's any kind of noise, or we can train our sensors to find the noise of intrusion as compared to that of the noise of a animal, or noise of any kind of bird over there. Okay, so we can use these sensors for I mean for checking up, keeping a check on the noise level of the surroundings. Then medical applications. See, sometimes what happens is it is not possible for the patient, or the I mean for the doctor to be physically present at the patient's site. So what they do is these days, and we have seen this application in COVID times also, that what people were doing was doctors were monitoring patients wirelessly. Okay, so that makes a very positive case for the wireless sensor networks. Again, this 5G, the demand of this data speed and internet speed is increasing day by day, and we are focusing on wireless connectivity as compared to that of broadband. I think 50% of our population might be using the wireless signals only, or basically the internet on their mobile phones in order to use internet. Okay, so we are moving from broadband connections to wireless connections. There's a very very recent example of that also. There's this thing called Starlink. This is a company by Elon Musk, where he has put a constellation of satellites which will provide internet to the entire Earth. So we are doing away with the all the broadband and Wi-Fi kind of thing. You can just connect to that Starlink. You put a code over there, and your phone is ready to connect to the Starlink, and you get the internet through satellites, and that's a very high-speed internet over there. Then we are using these wireless sensor networks to find they find application in the agriculture field also. What happens in case of agriculture field? We are monitoring our what do you call uh, we are basically monitoring our all the fields or the farms for pest attacks, for all the diseases, for the crop diseases and everything. We are putting this MIT. I was reading about a article where MIT have put a sensor inside the seeds, and it keeps a track of all the development cycles of the crop, and it relays the real time information to the servers. Okay, so that we can know when what amount of water is to be supplied to the crop, what amount of fertilizer is to be supplied in order to have the best possible growth and productivity. Then again, landslide detection comes under the environmental applications of WSN. Then we come to the challenges we face in WSNs. We have quality of service. See, because of the wireless thing, quality suffers a lot. Then we have security issue. Anyone can come and intrude into the network if that is not secure. Then energy efficiency, that is a very crucial part of the wireless sensor network. Sensors are very small in size. We cannot and sometimes they are placed at places where you cannot change their battery. So that energy efficiency becomes a very crucial part of the wireless sensor networks, as we need to put algorithms and we need to put sensors at place and in such a situation where it requires minimal amount of energy, and so that they can survive for the longer period of time. Then we have network throughput. Again, network throughput suffers if the quality of service is not up to the mark. Performance, right? See, if I want location of a place from the sensors, and if I'm not able to get the accurate location, then there's no point in getting that location. Okay, then they should have the ability to cope. For example, if one node fails, then there should be a uh, contingency plan where you can shift to other nodes in order to get the same data from there. Then scalability to a large scale of deployment. And scalability to a large scale of deployment basically means that the it is very easy to deploy wireless sensor networks at a very small place, but when we talk about deployment at a larger places, there are a lot of challenges, there are a lot of interferences, there are a lot of there is a loss of line of sight and diffraction, refraction, reflection. There are a lot of problems over there, so we have to see all those challenges also. Let me quickly Shababji, how much time is left for me?
Sir, you can conclude this whole thing in 5 or 10 minutes.
Okay.
Yes.
Okay. So let me just conclude. So basically, my research area is localization in wireless sensor networks. What I do is, uh, we all get location from our phones and devices where GPS is connected. But on the downside, we see that whenever we are using GPS, for example, you're using GPS on your phones also, you see that if you switch on GPS for a longer time, your battery drains at a very high speed. So, for example, I am putting sensors in a forest, and I want to find the location of that of the place where the forest fire has started, and I'm not if I use a GPS over there, the sensors are of very small size, like 1 inch, 2 inch. How much battery would they have? So I have to shift to a solution where I do not need GPS to find the location. So what I do is basically localization means in order is to find the location of the wireless devices put in a network. So what I do is we put some nodes which know their location. Either we have put those nodes by ourselves at a fixed defined position, or we enable them with the help we enable them with GPS. Okay, so when we enable them with GPS using those nodes which know their location, those are called your anchor nodes. These are your these are your nodes which either know their location or they are GPS enabled so that they can find out their location. So using those GPS nodes or the anchor nodes, we are finding the location of all the wireless sensor nodes that are present in the network. So this is basically the research area where I'm working on. Okay, so I guess I'm running short of time, so I might not be able to go into detail. So that is basically the basic forte where I research on. If like I do have a two or three more slides, but it'll take more time. So let me just conclude with that. So my research area is that only, where I'm finding and increasing the efficiency of algorithms which are already present, and designing new algorithms where I can find the location without the usage of GPS. Okay, so that's it from my side in terms of location, wireless sensor networks, and in terms of databases. Thank you so much.
So do we have any questions from the audience? Hello. Okay, sir. So I have a question.
Yeah,
Uh,
please.
so how these days database actually read by the people using AI and machine learning? So
Uh,
database is itself is not actually is readable to the user. So how
yeah.
people is actually using the AI and ML as a research area is different, means how they can able to differentiate their research area from AI ML to database.
See, what happens is what they're doing is what people are not actually doing the original research kind of thing. What they're doing is, what they do is, for example, they say we want to do application of this machine learning and artificial intelligence in terms of health management systems. So what they do is, we have predefined algorithms of these AI and ML, and they are directly imported, and they are directly applied on the data which is already available to us. So in this thing also, where when you talk about
Means they
the
are building
implementation,
building as an application, not as a research.
yeah, no, see, what happens in case if you're looking for database as a research field, what you
Yeah.
do is you basically start with the problems over there, and then you can apply machine learning and artificial intelligence as a method to solve that problem, and not the other way around.
Okay, sir. Okay, sir. Thank you so much, sir.
Okay.
So for this clarity. Okay, I would like to extend my gratitude to our speaker as well as all the members present today. So respected the head of the department, Professor Dr. Devati Mishra, ma'am, all my colleagues, and all the students of this end of the department who have joined the webinar. So this was really a lovely, or we can say that such a trending topic presented by our honorable speaker. And so I hope you all understood a lot of things about this two areas. And thank you again, sir, for so
Thank
actually taking.
thank you so
Uh,
much.
thank you
Thank you
for
so
your
much.
time from your busy schedule, actually. And
Thank
thank you again. And having said that, I would like to end this today's session. Thank you, everyone, and have a wonderful weekend. Goodbye.
Goodbye.